Hello everyone, let's solve this mock test for quiz 2 for mathematics. Okay, so let's get started. So this question says which of the following statements are correct. Okay, so the domain of the function under root of minus x minus 2 multiplied by x minus 3 multiplied by x minus 4 multiplied by x minus 5 is in the closed interval 2 3 union 4 5. Okay, so see, let us write this function here. Minus 3 x minus 4 x minus 5. Okay, so to make this function defined, we need to see that minus x minus 2 x minus 3 x minus 4 x minus 5 has to be greater than or equal to 0. Okay, now multiply both sides, okay, by minus 1. So what we'll get x minus 2 x minus 3 x minus 4 x minus 5 less than equal to 0. Okay, now we can make the sign scheme of this. Okay, so we are having 2 3 4 and 5, and its sign scheme will go like this: plus minus plus minus plus. Okay, so according to this, the domain is the minus part, in which there is minus, and that too in the closed interval. Okay, so 2 3 union 4 5. So this option is the correct one. Okay, very well. The next says that if f of gx is equal to g of fx, then f and g are inverses of each other. Okay, so by the very definition of the inverse of a function, we know that if f of f inverse of x is nothing but equal to, sorry, we can write it like this: f of fx, f inverse of x is x, and this is also equal to f inverse of fx. Okay, so by relating from this definition, we can say that if f of gx and g of x is equal to x, then f and g are inverses of each other, which if we do an analogy with this definition of the invertible function or the inverse of function, becomes correct. Okay, so the next question, the next option says that the function f of x equal to x cube plus 5 is differentiable everywhere. So we know that the graph of x cube is like this. Sorry, yeah, it's a bit terrible, but yeah, we'll manage. Okay, this is smooth over here. So so this is y is equal to x cube. Now if we'll add 5, then this graph will just move 5 units upward. Okay, so this will become like this. This point will be 0 5. So we can see that this function doesn't have any abrupt changes in it. Okay, it's smooth everywhere and continuous. So we can say that yes, the function fx is equal to x cube minus x cube plus 5 is differentiable everywhere by just looking into its graph. Okay, so this is also done. The next option says that that the polynomials this and this leaves the same remainder when divided by x minus 2, then the value of a is minus 3 by 2. Okay, so agar if we take this as fx, okay, and this as gx, then what we can say by the remainder theorem for the polynomial is that f2 is equal to g2. Okay, then by just solving I am putting the value of x as 2 in this and this, so we'll get 8 plus 4a plus 10 plus 7 is equal to 8 plus 8 plus this is 6, okay, plus 2a. So it will become 4a plus 25, and this would become 16 plus 6 would be 22 plus 2a. So it will be 2a is equal to minus 3. This is equal to a is equal to minus 3 by 2. So this option is also correct. Okay, so we have done this question. All options are correct. Next. So in this question we have to check whether this thing is differentiable or not. Okay, so let us check. Consider the function defined as follows with n belongs to R. Fx is equal to 5ex plus mx if x is less than 0, and 4x square minus 3x plus n if x is greater than 0. Choose the set of correct options. Okay, so f is continuous but not differentiable for any choice of the values of m and n. So you know that until we define what is m and n, we can't even say that f is continuous. Okay, because this might occur that this function comes like this and the other part of this function starts like this. Anything can happen, but until and unless we define m and n, we can't say anything. Okay, it says that any choice of values of m and n, which is wrong, because there will be a certain or one value, or most in the extreme case more than one values, but not all values that would make this function continuous but not differentiable, or continuous but differentiable. Okay, so this option is wrong. Okay, if n is equal to 5 and m is equal to minus 8, then then f is continuous and differentiable everywhere. Okay, so let us just see what are the condition of. So limit x tends to 0 of fx has to be equal to f0. Okay, for continuity. Okay, so for continuity this has to be true. Now taking the LHL, left hand limit, it would give me what? A limit x tends to 0 minus, that means x is approaching from the left side of 0. So we'll take this case, which is nothing but 5e to the power x plus mx. Now if we put the limit, we'll get 5 and plus m into 0, that is equal to 5 only. Okay, now we are seeing the LHL, RHL. For RHL, what we'll be getting? Limit x tends to 0 plus, that means the value of x is approaching from the right side of 0. So we'll take this value of the limit, which is nothing but 4x square minus 3x plus n, and this would become, if we put the limit again, because there isn't any problem here, put the limit. Okay, we are just putting the limit and we are getting this will become 0, this becomes again 0, and n. So n is the, so the limit to exist, we need that 5 must be equal to n. Okay, so here we can see that this condition is okay, and we can also see here that value of m is not at all important. It can be anything. Okay, because it is at last it is going to become 0. Okay, so it doesn't matter if it is 8 or if it is if it is 100 or anything. Okay, so if n is equal to 5, then value of m doesn't matter. So this option, okay, let us test if this is true or not. Okay, so at this point we are having n. Okay, so yes, n again n, so n is equal to nothing but 5. Okay, so according to our option, that n, if n will become 5, then everything will be, you know, uh, in its good phase, and we'll be able to solve this question. So f becomes continuous. But what about differentiability? See, neither of these two functions are, you know, non-differentiable at any points, and in this functions also. Okay, so we can say that if this function is continuous, then differentiability is established. Okay, so this option is correct. And again, if f is differentiable, so when is f differentiable? F is differentiable if this thing is satisfied, you know. Let us take that we are taking this set of value, because this question doesn't state that what we have to take. So f dash of x would become, for limit x tends to 0 minus, so for 0 minus we'll take this is nothing but 5 e to the power x plus m. Now if we put the limit f dash x, limit x tends to 0 minus, becomes this becomes what, 5, because e to the power 0 is 1, 5, and m we are having this as our value. Okay, so minus 8, so it is minus 3, so this option is also correct. And you know, this option is wrong. Okay, no, actually this option can be right, because this is true when m is equal to minus 8. But what if m is equal to 0? We can take it. Okay, so if it is differentiable, then m is equal to 0 is also making it differentiable, so this point is also correct. Okay, next. Yeah, this question. So in this question we just have to, you know, see, we just have to do just by looking one option or two options, just, and looking whether the options are correct or not, because there is nothing to be confused here. So we are having fx as x e to the power minus x plus 1. Okay, we have to choose the option which represent the correct matching of the given function in column A with its tangent at 0 1. Okay, with its tangent at 0 1. Okay, so let's see. So for tangency we need to find its derivative, first derivative, which is equal to, here we have to use the product rule. X, we are leaving x and differentiating this, we will be getting minus e to the power minus x into 1, and now we leave this and differentiate this, then so we'll be getting, okay, e to the power minus x, we can write it as e to the power minus x e to the power minus x. Okay, so yeah, so we got this. So f dash x at 0 1 will be what? Since a value of x is 0, so e to the power minus 0 minus 0, which is equal to nothing but, which is equal to nothing but 1. So m, or the slope of the tangent at 0 0 for this curve, is actually what? 1. So the equation becomes m x minus x1 is equal to y minus y1. M is 1, x minus, we are having x as 0, is equal to y minus 1, which is equal to y is equal to x plus 1, and 1 will be mapped with d. Okay, so 1 will be mapped with d, because there isn't any correct option looking over here. So 1 will be mapped with d, and the graph of d would definitely not be this. Okay, this won't be the graph, because this is e to the power minus x. Okay, and again this is not the line which we are thinking, so this can be the graph. Okay, since x is also influencing the graph, so yes, this can be the graph. So okay, so 1 to d to 3, this option is correct. Let us check if there is any other option. Okay, 1 is again associated with A, and no, it's not correct. Okay, so this option is correct, right? Yeah. Let's check for the other one. So the other curve we are having is fx is equal to e to the power x plus e to the power minus x upon 2. So fx is equal to e to the power x upon 2 plus e to the power minus x upon 2. F prime x would be half of ex plus half of e to the power minus x into minus 1, which is nothing but half of ex minus half of e to the power minus x. So f dash x at 0, 1 would be again, this would be 1 and this would be 1, so 0. Okay, so the slope here is becoming 0, so equation of line would be m x minus 0 is equal to y minus 1, which is this becomes fully 0, y is equal to 1. Okay, so this is the correct equation for this curve or this function. And let us see we are having this curve only with this y is equal to 1 line, and as a matter of fact I can tell you that this represent a parabola. Okay, so this is a parabola, so we can say that 2 is associated with c and c is again associated with 4. 2c4, this option is correct. So again we are checking for the other function. Yeah, so the function is fx is equal to 1 minus ln of x plus 1. So it becomes, after differentiating, minus 1 upon x plus 1, since this becomes 0 and this will become minus 1 upon this. So f dash x at 0, 1 would be nothing but minus 1, because this is 0, x is 0. So m is equal to minus 1. M of x minus 0 is equal to y minus 1. So y is equal to 1 minus x. 1 minus x we are having here. So okay, and 1 minus ln of x plus 1. So let us first check the options. Okay, 3 is associated with a. Okay, 3 is associated here is b, which is wrong. 3 is associated with a and the graph is 2. Since this option can only be correct, so I think that this is yes, this is the correct option, because the graph also matches. Okay, 2, yes, okay. So this is your question number, I think 4 or something. Yes, next. Yeah, this one. Suppose Lx is the best linear approximation of the function fx is equal to 3x into cos sine 3x into cos 4x plus over root of 1 plus 2x at x is equal to 0. Okay, choose the correct set of options. Okay, very nice. Now let us move ahead with just this function in our hand, sine 3x into cos of 4x. Okay, plus, I'm writing it below, root of 1 plus 2x. Okay, yeah, this is the function. So after differentiation, this function will become cos 4x into cos 3x. Here, there is 1 3 also. Okay, minus 4 sine 3x into sine of 4x plus 1 upon this root of 1 plus 2x. Okay, so let us put 0 now. F dash of 0. this would give us the value of m, which is equal to, here is so we can take so this would become, this is equal to 1, because 0 cos 0 into cos 0 will become 1, and this is 3, and this is 0, and this is plus 1 or minus 1. Okay, yeah, plus 1 or minus 1. So let us take first the plus 1. Okay, plus 1, so it would become 4. So we have the formula of Lx as Fa plus m x minus a. Okay, so Lx would be Fa. What is the value of Fa? Fa would become 1. So there would be more values over here because of this root. Okay, yeah, so this would become 1 plus 4 times of x minus 0. This is Lx is equal to 1 plus 4x. Okay, so this option is correct, and there is a unique, not unique, because we have only considered plus 1 here. Okay, we can consider minus 1 also, but here here it won't be minus 1. So there can be two possible linear approximations. Okay, so this one is correct, but another one is not correct. Next. Yeah, this question is an interesting one, and I'm not going to solve it because it is going to be very lengthy. Okay, so yeah, it says that Nisha researches on various cosmic signals. She found that a harmful cosmic signal of the form y is equal to 3 to the power ax has the potential to harm the entire life form of the planet Earth. For her interest, she found two cosmic signals which are of the form fx is equal to log with base 2x plus 3, 6x square plus 23x plus 21, where this and this conditions are given which for our ease, and gx is this particular function. Okay, yeah, and this which can destroy this harmful signal. She found that when a harmful cosmic signal passes through the intersection point of fx and gx, its effects nullifies before reaching the earth. She has to find the value of a so that she can prevent the harmful cosmic signal from reaching the earth. Okay, based on this information, answer the following question. Okay, so which one of the following statement are correct, but in the website it is given a single correct answer. So see, this option is obviously correct because it is given in the question that y is equal to 3 to the power ax must pass through the intersection point of fx and gx to protect the life form on earth. Okay, this is correct. And to find the information about the root the roots of this these two functions, we need to first put them like this, gx, and then solve them. Okay, so this is log of 2x plus 3 and 6x square plus 23x plus 21 is equal to, or we just can take this as okay, equal to minus log of 3x plus 7, and here it is 4x square plus 12x plus 9 plus, okay, put it here and then factorize this and this. Okay, and after a long after long calculations and factorizations, you will get 4 values of x. Okay, 2 from here, no, not 4, I think you will get 5, yeah, 4 or 5 values of x, which you will test by keeping it here. Okay, if this becomes negative, then that value won't be considered as feasible for the answer. And if this become positive and this also becomes positive, then it's okay. Okay, then you can go with that value. So there would be only one x that would satisfy this. Okay, so you can see that the equation fx and gx has only one real root, and this is the correct option. Okay, now what is the value of a? So I think if they have cancelled this to be multiple choice, then this would be a bit difficult, but yes, still let's solve it. Okay, so x would be minus 1 by 4. Okay, so if it would become minus 1 by 4, then we need to solve it by keeping here. Actually at this point x is equal to 4. Okay, this function and this function are actually intersecting. Okay, so if they are intersecting with one another, this means and this function, or we can say yes, this is the function, this curve is passing through it, so we can keep fx is equal to 3 to the power ax at x is equal to minus 1 by 4. Okay, so put it, and this would result in the value of a as minus 4. So the value of a is actually minus. Okay, next. Yeah, this question is also a very important, or I think interesting one. A group of biotechnology students were creating a genetically modified plant. They found that the expression this gives the increase in the number of leaves on a plant as function of days. On 0th day, there were 10 leaves. By the end of 36th day, the number of leaves started decreasing as function gx is equal to this. Okay, so we have function fx as a to the a upon 1 plus e to the power minus 0.5x. Okay, and the function gx, which is a decreasing function, as 10 into 2 upon this is x by b plus 100, and eventually there were no leaf on the plant. That means that the graph is going to 0. Okay, as you can see in the graph. Okay, very nice. So yeah, consider f as j is represent the number of leaves on the plant at the end of xth day. Very nice. So we are asked to find which of these are correct. So at this point of time, both the functions are coming to the same point. So this is obvious that, okay, let's find a first. Okay, so 1 plus e to the power minus 0.5x is equal to 20. I think on 0th day there were 10 leaves. Okay, 10 at x is equal to 0. So we'll put x is equal to 0 here to get this. A upon 1 plus e to the power 0 is equal to 10. So a is actually 20. So we got a is equal to 20, which will help us in further calculations. Okay, so this the first thing is that the first option is correct, because we can find the value of b, because both the functions are taking the same value at this point, which is x is equal to 36. I think because it says that by the end of 36th day it starts decreasing till 36th day it is increasing, and then it starts decreasing. So at this point the values are same. So yes, b cannot be determined, so this is a wrong statement. B can be determined. Okay, so let us find b.